Okay, electron is a spinning ball. For a child, it's yes. But for deep physics analysis, electron is not a spinning ball. It has a wave-like property. I'm trying to explain here in very simple way what I have studied in my own research work after studying Dirac equation. I'm going to explain what is a spin, how we think a spin, and what is the beginning of a spin and how it will look. What will be the physical intuition of a spin in very simple way. Look at on here. The electron spin. Topic is this. Matter complex wave of Dirac particle. For relativistic electron, when an electron is moving at high speed, a speed closer to light, then it comes the property of spin. At ordinary velocity, a spin isn't appear. So, see, especially Dirac particles or relativistic electron. The wave function, matter wave function, is a complex wave. It has an amplitude part and a time part. But see, figure the difference in this Dirac Dirac matter wave form and Schrodinger matter wave form. In Schrodinger matter wave form, there were just one amplitude component, but in Dirac matter wave form there are 4 amplitude components, and from here a spin begins. The existence of a spin appears to begin. Okay, see here. According to Dirac, a free electron, when electron is free, means it's not inside an atom or it's free in a space. Suppose getting out of atom or coming towards an atom. A free electron, the matter wave function in one state is this, a constant. This is the first psi1 amplitude, the second is 0, third is 0, and the fourth, this one is 1. Why it happens like this? For this we wrote 1, for this here 0, for this here 0, for this here this. Why? To know this, you have to see my other video. I had already made a video over this, and see the name of the channel, Physics and Universe, is my YouTube channel, and go there and watch this video. What is a spin? There I explained this, that the value of this is this, and Dirac took 2 amplitude as 0, because why? The 4 amplitudes for a particle, for electron at relativistic speed, these 4 amplitudes are the 4 state, means vibration along 4 type of waves. Out of which 2 are for positron, for antiparticle, and to know that you have to watch another video that I will make. So here we have to take always 2, 0, and rest 2 as this and this. According to Dirac, this is a smaller amplitude. I mean, this component is vibrating as a small amplitude, and this one is larger, means the 4th component of amplitude is vibrating at large amplitude, and this at a small amplitude. Okay, there are 4 amplitudes. According to Dirac, they all lie along one x-axis. Means Dirac has explained this as one-dimensional analysis along x-axis. But I figured out, maybe it is right or wrong, but I figured out I'm saying what I studied. I figured out here that they are, according to Dirac told us that these amplitudes, the component of amplitude, are orthogonal, means they are independent to each other. None of them are related to each other. What would be that mean? What is the meaning of that? What is the simple meaning of that? Orthogonality means simply shift by 90 degree, rotation by 90 degree. And that's why maybe I thought that they have this and this, these 2 are 0, this and this have rotation of 90 degree. In other state of the same electron, here some constant A3. Now in this state, the first component is 0, taken as 0. Second component as this, which is a smaller vibrating amplitude. This component has larger vibrating amplitude, that's why it's 1, and the fourth one is 0. So values are same for smaller and larger amplitudes, but the shift is different. Here second one is 0, third one is 0, here first is 0 and fourth is 0. And from here you are getting an intuition of what is a spin. Something which was in one state here and another state here for a relativistic electron, and that's the beginning of a spin. This is spin down state, this is spin up state for a free particle. Now see, Dirac again analyzed a bound electron confined in an atom. Means this time the electron is in a atom, means it's bound. And notice one thing, according to Schrödinger equation, Schrödinger analysis, when an electron inside an atom, it has some back and forth, like hitting and getting out and facing the potential of attractive potential of nucleus, it creates a standing wave. So inside an atom, electron is not like a free electron, it follows some standing wave like pattern, and the best way to explain electron inside an atom is the standing wave pattern, okay? And the same analysis has been carried by Dirac here, a bound electron confined in an atom. So a standing wave pattern for this state is this. This is standing wave pattern of this. And for a spin up state in free state, a spin up state in bound state for an electron, the standing wave pattern is this. Notice. But the analogy of this four components of amplitude is in bound state also. This is the smaller vibrating amplitude. This is larger vibrating, and these two are 0 as the spin down and a spin down in bound state. Similarly, spin up is here for free particle, and the same electron inside an atom. This is a smaller vibrating amplitude component, and this is larger vibrating component of amplitude. Notice, you can figure out differences. I thought here, and I thought that once they are orthogonal, they have some shift of 90 degrees, that's all. Now see here, this type of component of amplitude arranged in a column matrix is called a spinor. And my goal to make this video, I try to explain in this video that how easily understand, not a lot of mathematical calculation, not a lot of uncertainty. Quantum mechanics has a lot of uncertainty, and we have to work to reduce that uncertainty and give some physical instinct. And in that way, I think that there must be some analysis going through this four components of amplitude. For a free electron, quantum physicists use longitudinal wave type of structure. No, matter is not longitudinal, neither transverse. But for ease, they feel that a free electron behaves, the matter wave of free electron is much similar to longitudinal. It has differences also, but we use longitudinal wave to give a physical intuition. And that's why, to understand here, see, for a free electron, the matter wave is going along x-axis, means the axis of propagation is this. Axis of propagation is x. And so the larger component is along x-axis, and the smaller component is 90 degrees to it, maybe in x or maybe in y. Here I think it's in y, and the spinor for this will look like as this. See, a spinor for this is, this would be along y-axis, 0, 0, and this would be along x-axis for this. And again for this, the spin analysis, larger component is along the axis of propagation, means 0, this along z, this along x, and this 0. That's the analysis, means it will be along this axis. The same thing is in band electron also, and in that case earlier in Dirac this quantum state, spin then quantum state for bound electron. Here there in Dirac quantum state for bound electron, here it was some other function. Now I tell that if they are orthogonal to each other, then this goes along x-axis, axis of propagation, then this must be in y or z, as here for free state. So in bound state also we use that function. And here some constant that is real according to me, no y, because I already shifted it by 90 degree, and due to axis it has shifted, so I removed I. And the same goes to here. Here the smaller component is along z-axis and the larger component is along the axis of propagation. Now why L dash? Earlier L here and here, they both are same. Here and a smaller component here in spin-up state for bound electron is this, again some constant, that is I think real, and along z-axis, and the larger component is still along the axis of propagation. I use L dash for a smaller component and L for larger component. L was in the Dirac equation. Why L? L is the length of the confined atom, means the range up to which the electron is oscillating to make a standing wave. And L dash is different. I thought that transverse to this is vibrating along the direction of axis of propagation, and this is orthogonal to, and the vibrating amplitude, the range of amplitude is smaller than this. I think this is very, very smaller than this. That's why I take here L dash is very, very smaller than L. Means I thought the larger component is vibrating along the axis of propagation. That's why the range is L. But this is orthogonal to this, the smaller component. The range of vibration of a smaller component is way smaller than L. According to me, L dash is way smaller than L. Now see, the switching of this smaller component from first to second and larger component from fourth to third, it gives a shift, and that is the spin. A spin up, a spin down. It's not like revolution. It's not like a spinning ball. It's like shift in the amplitude. How? Now understand. I have some handmade apparatus to show you how we could think in common world for posit. I discuss the longitudinal wave type analysis for the longer component, and the smaller component of amplitude is vibrating at a smaller amplitude, and it's orthogonal to longer component. That's why I thought it as transverse, and that's why in bound state the transverse wave like nature for electron wave, matter wave, is also quite stronger than free state, and that's why I thought this is a very simple model, handmade model. This is in bound state we need standing wave pattern. But it's not that standing wave pattern. It gives you the sense of electron spin, how electron looks like in free state and in most of the case in bound state. Let's see. This is a longer component, larger amplitude, larger component of amplitude which is vibrating along the length L inside an atom. And this is longitudinal wave. And this spiral portion, a smaller component this is this, which is a spiral over this, and it has also some vibration. It goes like this. You can feel it has some transverse like effect, and it is quite effective inside an atom rather than free state. And here I need some standing wave like analysis, but this is quite simple model to explain half spin of electron. Why we use 1/2 as value of electron spin. See, this is longitudinal wave-like structure for longer component and transverse wave-like structure for a smaller component. That's the electron 4-component amplitude matter wave for drag particle. Now see, let me to analyze how it goes on. Suppose this is the amplitude of a smaller component. We can give oscillation in larger component like this, that is longitudinal behavior, but this goes along transverse like wave, and it's going like this in the same state, now this and this again. Earlier it was like this, now it is like this. It comes after 2 revolutions here. Understood? That's the electron spin according to me. Now I'm trying to show you one more easier way why we use half integral value for electron spin. Let's see. There are drag belt process, you know that, either the Feynman carrying jug inside his hand like this and goes for a rotation, and after 2 revolutions it comes in the same initial state. So electron as a particle comes exactly in the same initial state after 2 revolutions. What comes? Mass, charge, shape and sizes comes in the initial state after just 1 revolution. But these components of amplitude takes 2 revolutions to come in the initial state. And that's why we use 1/2 as integral spin value of electron. Let's see. I'm teaching you how easily it goes on. This is my design. This is the shape of the electron spin, one larger component and one smaller component. Larger is expressed by the help of longitudinal wave pattern, and smaller is expressed by the help of transverse wave pattern. Now see why 1/2, how it goes. Here, showing is tough, the vibration here, see. This plate is showing the larger amplitude. Larger component is shown by this plate, and the smaller component is shown by this. Now see, as I told you that for half integral spin, the larger amplitude, which is longitudinal wave type, has time period twice than the time period of this smaller component, which is transverse like. Means the transverse like a smaller wave pattern has frequency twice than the frequency of this longitudinal wave pattern. Now see here, the plate is representing the longer or the bigger component, and the spoon is representing a smaller component. Let's see. Here in this stage, they both are exactly in the same phase with everything in the same initial state. Now see, it has twice the frequency than this, means it has half the time period than this. See here. Now see, as the spoon is faster than the plate, a spoon comes in the initial stage after just 1 revolution, but plate is still in the half revolution. To get exactly in the same position, we have to rotate again. So to get exactly in the same position, same initial state from where we started, a spoon has to cover 2 revolutions, plate has to cover just 1 revolution, and that's the physical intuition for electron spin. Means electron is not a rigid body, rigid ball-like structure. It has something confined in layers inside it, and that layers are like this. So one completes in 2 revolutions, other completes in 1 revolution, and that's why they're in the same phase. That's we use 1/2. Now see, I told ChatGPT, according to my analysis, to make some animated like video to make you understand how easily you can solve this electron spin. Why we use 1/2? Now see the value. I'm showing you on the phone. See here. I made this animated video by the help of ChatGPT. Is it clear? See, she's my sister helping in shooting this video. She also shoots video over physics. See, this bigger is a longitudinal wave type analysis, and the dancing of this is like this is the transverse like, and that's why we use 1/2. Means electron is not a spinning ball, it's a dancing tornado, not revolving tornado, but dancing tornado like a string, like leech. We have seen leech, and that's why we have to believe that string theory is the probable future fundamental theory for electron and the fundamental particle. We think we should believe in string theory. That's all for today. And comment me, like my channel, subscribe it, and tell me my errors here. I'm inviting that. Thanks for watching.